Hey girls, this is your lesson 4 on coordinate geometry of the circle, and sorry, now it's a bit shiny, and it's based on the intersection of a line and a circle, which is something that you would have come across in algebra. Do you remember when we were doing simultaneous equations? So hopefully, some of the concepts will start coming back to you a little bit. But just a brief introduction then, right? So say we have a line that intersects the circle, and obviously the distance from the center, or the line that from the center to that intersecting line creates right angle, doesn't it? 90 degrees. And what we can say is that there's 2 points of intersection here. So if there's 2 points of intersection, the radius length is actually greater than the perpendicular distance from the center to the line, right? Because remember, the radius goes from the center out to the edge. So the radius length would actually be bigger or greater than the perpendicular distance from the center to that line. Okay, makes sense. Solving between the line and the circle gives us 2 points, okay? So say like the line, solving between like the line or the intersection of the line and the circle gives us 2 points, okay? Now, this is what we've come across up until now. It's a line that meets the circle at one point, which is called a tangent. And obviously the distance from the center to that line creates right angles on either side, but also is equal to the radius. So 1 point, or 1 points, I suppose 1 point would sound better, of intersection. The radius length is actually equal to the perpendicular distance from the center to that line, okay? So if I said to you get the perpendicular distance from the center to that line, it's actually equal to the radius. So solving between the line and the circle gives 1 point. So do you know this is like a question that we did in the last section where we were finding the intersection between one of the lines and say the tangent to that line. And finally then, where we have a line that's outside the circle and there's no points of intersection, right? So the line doesn't cross the circle at any intercept. And we can say that the radius length is actually less than the perpendicular distance from the center to that line. So solving between the line and the circle will not give real number values, okay? So solving between the line and the circle will not give, so you won't get any real values for crossing the circle. It'll make more sense when we have a look at a example. So worked example then, right? So say if it said, show that the line 3x minus 4y plus 10 is equal to 0 is a tangent to the circle x squared plus y squared minus 10x equals 0. Now, you can see that this is going to be the equation of this line here. Now, they actually drew it, so you can see that it's a tangent, but how do we prove it? What concepts do we use? So let's think back to what we have here. So look at this here. So the radius length must be equal to the perpendicular distance from the center to the line. Okay, so let's think what we have, right? So we have the equation of the circle in the form a second degree equation, isn't it? It's not in the form x squared plus y squared is equal to r squared. It's not in the form x minus h all in brackets squared plus y minus k all in brackets squared is equal to r squared. It is in second degree equation form. We have x squared, we have y squared, so the coefficients of x squared and y squared are 1. We do have 2gx. We can really say that 2fy is 0 and c is 0 as well, okay? So f is 0, but we can work out g here. So that's what we'll do, right? So if the line is a tangent to the circle, then the perpendicular distance from the center of the circle to the line will be equal to the length of the radius. So center 5, 0. So that's got from saying that 2gx is equal to minus 10x, 2g is equal to minus 10, g is equal to minus 5, center is minus g, so that's 5. Then we'd have 2fy is equal to 0, 2f is equal to 0, f is equal to 0. There's no such thing as minus or plus 0. And then you know to get the radius is square root of f squared plus g squared minus c. So we stick in, what do we have for g? What do we have for f? This is my g, this is my f. Put in my minus c, which is, there is no c here, but we do take it like, you know, when you're doing the minus b formula and if there wasn't a constant, you take c as 0. Put it in, so we get 5. So now let's get the perpendicular distance from center 5, 0 to that line. We'll take our a to be 3, our b to be minus 4, and our c to be 10. plug it into your little perpendicular formula, which you're used to. It's equal to 5, so therefore that's equal to the radius length as well. So therefore we have confirmed that the line is in fact a tangent to the circle. Okay? So another type of question, right? This is kind of bringing me back to your algebra. Show that the line L, which has the equation 5x minus y minus 20 is equal to 0, does not intersect x squared plus y squared minus 2x minus 2y minus 2 is equal to 0. So bringing it back to algebra and bringing it back to what you know. So if it does not intersect, the radius length is going to be less than the perpendicular distance from the centre to the line. So let's go back to what we mean. So if it doesn't intersect, it would be something like this, where the radius length is from the centre to the edge of the circle. That's going to be less than the perpendicular distance from the centre to that line. So let's think about what we can find. So let's put down our equation. First of all, it's in second degree form here. So it's x squared plus y squared minus 2x minus 2y minus 2 is equal to 0. Let's work out both the centre and the radius. So centre is 1, 1. You know how to work that out at this stage. 2gx is equal to minus 2x. 2g is equal to minus 2. G is equal to minus 1. This is minus g. So that's going to be 2. Then we have 2fy is equal to minus 2y, 2f is equal to minus 2, so f then is equal to minus 1, and then this is minus, so minus g minus f, we'll have 1 then, and then we have c is equal to minus 2. So let's do our radius, fill in what we have. So let's now get the perpendicular distance from the centre of the circle to this line to prove whether it doesn't touch the circle, and basically it's outside of the circle, it's not going through it at all. So we will fill out our formula. Our A is 5, our B is minus 1, our C is minus 20. Be really careful when you're filling in your signs in particular, because these left some me down in previous questions. And what do we get as the perpendicular distance, which is approximately 3.4. What do we say the radius was for a circle? It was 2. Isn't that greater than the radius? So that it has in fact confirmed, as the radius length is less than the perpendicular distance from the centre of the line, from the centre to the line does not intersect the circle and it's outside it. Okay, another bit of information is the locus of a point, which can come up in a question. So what is the locus of a point? So the definition. So a locus is the path traced out by a moving point satisfying given conditions. What does that mean? So let's look at what we have here. We have point A. Okay. And the locus is the path traced out by a moving point. So it creates, I suppose, the shape of a circle. And we have the radius then going from the centre of the circle to that point. So basically, it's kind of like the distance from the centre to that point would be equal to the radius in a sense. So if we have point A, which is minus 12, 0, and B, which is 0, 0, and P, which is x, y, they're 3 points. If AP, or the length of AP, is equal to 5 times BP, show that the locus P is a circle. Okay, so show that the locus P is a circle, right? So let's just fill in what we have. AP, the length or the distance, if you look at it like that, is equal to 5. So we'll get the distance from A to P. Mark in x1, y1, mark in x2, y2. Fill it into your formula. Always write down your formula first of all. They didn't do that here, but I would. Fill in, and then we're saying that's supposed to be equal to 5 times the distance from B to P. x1, y1, x2, y2. So simplify it. Okay, they got rid of the square roots by squaring both sides. Remember, if you square both sides, that gets rid of the square roots, but you also square the 5, which becomes 25. So simplify it even further, break it down as much as you can. We'll simplify, put our x squared terms together, our x's, or y squared terms together, our constants. Okay, and that comes out then to be x squared plus y squared minus x minus 6 is equal to 0. And because that is in the format of second degree term, where we have the coefficients of x squared and y squared are 1, we also have no xy terms, and it's in that format. What was the other The other condition was that the highest power is for x or y has to be 2, and that is here. So let's just revise, I suppose, this particular question. It's just telling you that the locus, it could come up as part of a question. And locus is the path traced out by moving point. So you might have a point A and it's the path that I trace it out, which forms a circle. And this particular question is just kind of getting you to use kind of that kind of concept or theory to show that the locus of P, if the distance from AP is equal to 5 times BP, that it is traced out, and that the P is the actual locus that would have traced out the equation of this circle here. And it is an equation of a circle because it is in the form, you could say, how do I know? Because it is in the format of a second degree equation. X squared, y squared, minus x, minus 6, coefficients of x squared and y squared are 1. The highest power of our variables are 2, and there's no xy term. Okay, and that is the lesson then on, say, intersecting circles. So I will give you some questions on those to try.